I'm Anil Kumar. Welcome to my series on strategies to solve mixture problems. We are actually looking into special cases where a quantity is removed and then replaced. Based on this, we have few questions to practice. You have already learned the formula to use and also some strategies. I'd like you to go through these questions, apply the strategies, and see if you could really solve these in a minute or less. Question number 1. 100 liters of pure milk is in a container. First 10 liter is replaced with water. Then this process is repeated 2 more times. That means 3 times in all. What is the amount of milk in the mixture, right? So remaining. So our formula was what remains is equal to initial amount times 1 minus what is removed over total to the power of n, right? So we want what is the amount of milk in the mixture. So we're talking about milk, right? So which remains. We started with 100 liters of pure milk. So initial amount was all milk, right? So 100, 1 minus. 10 has been removed from total of 100 only, right? And this has been done 3 times. So power is 3. You get the idea, right? So using this, you can actually find your answer. So what we get here is 100 times. When you take 100 minus 10, it becomes 90, right? So we get 90 over 100, which is 9 over 10 cube, correct? So 9 over 10 cube, which you could write as 100 times. So we have 9 times 9 times 9 over 10 times 10 times 10, right? So those two cancel away and you need to multiply 9 3 times, right? So we have 9 times 9 is 81. Some of you also will know what cube is, right? So we'll do 81 times 9. 9 times 1 is 9. 9 times 8 is 72, right? So 729 is a number which many students at this stage remember. So 9 cube is 729 divided by 10 gives us 72.9. Do you see that? So 72.9 liters is what remains, correct? So this is one way of doing it. So I'll call this as our method number 1. However, there is another method which some of you will love, and that is we are taking 10 liters, right? So that means 10 out of 100, as you have seen, is basically 10% removed, correct? That means 90% remains, correct? So every time 90% remains. Perfect. So what we could do is you started with 100, correct? So you could 100 times 0.9 times 0.9 times 0.9. Since 3 times it was done, right? So 729 and this 100, 3 decimals will give you 72.9 liters. Do you see that? It cannot be more than 100, right? So you can place the correct decimal 729 and the correct decimal place. Do you see that? So you could adopt either one of these methods to solve any of these questions, right? Okay, question number 2. 30 liters of pure milk is in a container. First 3 liter is replaced with water. Then again 3 liter of mixture is replaced with water. What is the amount of milk in the mixture? So straight away, when we say 3 out of 30, right? That means what? That means 1 out of 10 or 10% removed, right? And that means 90% remains. Is that clear? So as soon as you read your question, that should get into your mind, right? This is very important to understand. Now, we started with 30, right? So 90% remains first time, then again it is done. So again 90%, correct? So that gives you the answer. So 30 times 90 into 90 will give you the answer, which is 81, right? So 30 times 0.81, and now you can multiply. So 3 times 1 is 3 and 24, right? So we get 24.3 as your answer. Is that clear to you? So that much remains. Now this is your first method. You can adopt the second method, which is straight formula. So the formula here is what remains is equal to what you start with, initial over 1 minus removed over total, right, over number of times. So here we need to find what remains. We know initial is 30 liters of pure milk, so all 30, 1 minus removed 3 out of 30, right? And this has been done 2 times. Clear? So 3 out of 30 is same as, you could have written 10% also, 1 minus 1 over 10, right, square, and that is 90% removed, right? So it is 30 times 9 over 10, which is 0.9 whole square, and that again gives you 24.3 liters. Is that clear to you? So any of these methods could be applied. Here is question number 3, which says 80 liters of solution has milk and water in the ratio of 3:2, right? 20 liters of this solution is taken out and replaced with 20 liters of water. This process is repeated twice again, that means total of 3 times. Find the quantity of milk left in the mixture after every operation. So we want to do it after every operation, right? So you can go in steps and do it in all the operations. Normally, 1 or 2 operations are good enough, right? So we have 80 liters to start with, but it is in the ratio of 3:2, right? So we have 80 liters, but as far as milk and water is concerned, the ratio is 3:2, correct? So 3:2 means total of 5. So when you divide this by 5, what do you get? You get 5 times 1 and 30, which is 16 times, right? So out of 80, we have 48 is to 32, right? So this is from 80 liters, and that is your milk, and this is your total milk and water, correct? Now it says we can now apply the formula, what remains, right? So let's say remains. Find the quantity of milk left in the mixture after every operation. So you are starting with, this is your starting value, 48, correct? How much are you removing? So you also think like this, 20 liters, right? So 20 out of 80, we can simplify here, right? So that means 1/4, right? So 1/4 removed. Is it clear? 1/4 removed, right? So when 1/4 is removed, what remains? 3/4 remains. 3/4 remains. So what remains after first operation? So after first operation, 3/4 of 48 remains, right? So we can write this as 48 times 3/4. Is that okay? So this is very easy. The first operation goes 12 times, and this is 36. Do you see that? Now this is after first operation. Second operation, 3/4 of 36. So we could go 36 times 3/4, correct? 4 goes 9 times. We get 27. So this is after second operation. And after second operation, third time when you do it, 27 3/4. Correct? Now 1, 2, 3 times 2, 6, and 1, 7 divided by 4. That gives you 4 times 1, and this is 30. 4 times 7, 28. Then again 30. So that remains. Well, when we multiply 27 by 3, it is not 71, but it is 81, right? So 81 divided by 4 will give us, it will go 2 times, right? That is equals to 2 times 20.25, correct? So 20.25 will be our answer, right? So these are the 3 quantities which will remain, right? So that is how you should be solving this question. Let's move on and take question number 4 now. Question number 4 is 80 liters of pure milk is in a container. First 8 liters is replaced with water. then 16 liters of mixture is replaced with water. What is the percent of milk in the mixture, right? So we need to find the percent of milk in the mixture, right? So we can again use the formula here. So when we say 8 liters, right? So when we say 8 liters out of 80 liters, it really means 10%, correct? And when we say 16 liters out of 80 liters, it means 20%. So that is removed, right? So what remains is 90% in the first case and 80% remains. Is that clear to you, right? So we are starting with 80 liters of pure milk is in the container. First 8 liters is replaced with water. Then 16 liters of the mixture is replaced with water. So what remains is, we are talking about quantity, right? So we started with 80, we'll multiply by 0.9 and then multiply by 0.8. So that much remains. Now the question is, what is the percent of the milk in the mixture? Well, the total is 80, right? So percent milk is how much? Percent milk is all this, which is 80 times 0.9 times 0.8 divided by the quantity of 80 liters. Do you see that? Times 100. That is the percent. So 80 and 80 cancel. 8 times 9 is 72. So we get 72% as our answer. Right? So that is how we are going to answer this particular question. So I hope it is absolutely clear, right? The next question here is question number 5. It says, a container contains 200 liters of pure milk, 20 liters of solution is removed and replaced with water. So that means 10%, right? How many times should the procedure be repeated for the can to contain 145.8 liters of pure milk? So in such cases, we have to use our formula, right? So which is remains equals to initial over 1 minus removed over total, right? Times the number of times. Do you get the idea, right? Now it says 145.8 liters remains. So remains is 145.8. Initial is how much? We started with 200 liters of pure milk, right? 1 minus 20 liters is removed from 200, correct? So we'll write 20 over 200, which is 10%. I'm sorry, 200. And we have to find this value of n, correct? So how many times should be done so that we get that as our result? Is that clear to you? So we have to solve this. So let's divide this by 145.8. Let's divide by 200, right? On this side, it is 200 means 10%, right? So when you do 10%, you get 0.9 to the power of n, correct? 0.9 to the power of n. Now, see, mainly because it is 200 times 200 minus 20 over 200. Or you could also do this is as 1 over 10 and then 10 minus 1. Is that okay? Which is 90%, right? So we have to now figure out this. So let's divide this number by 2. What do we get? 2 times 7 is 14, and then we get 2 times 2 is 4, and then 18 is 9, right? And that is what we get, 729. Does that give you a link of how this is related with 0.9 to the power of n? And how many decimals we get? We get this divided by, there are 2 decimals here, and this is also a decimal, right? So we get this as 0.729, 3 decimal places, right? 200, and then it starts off. Now you remember this is n is 3. We know 0.9 cube is 729, right? So we know n equals to 3 is our answer. So in our first example, we did 0.9 to the power of 3 is 729. Very important number to remember, right? Otherwise, you can write powers of 9. 981, And when you multiply this by 9, you get 9 times 1 and this is 72, correct? Very important to remember. So I hope these steps are absolutely clear. Now let's take the next question, which is, from a vessel of milk, 20 liters is withdrawn and replaced with water. So we don't know how much quantity to start with. 20 liters of mixture is again withdrawn and replaced with water. So twice this operation has been done. The ratio of milk to water now is, so that remains as 25 to 24. How many liters of milk was there initially? So we don't know initial. So again we will say remains is equals to initial times 1 minus removed over total, right? So from a vessel of milk, pure milk, so this total and initial is the same amount. Do you get the idea, right? So this initial and that total is the same amount. Now another thing is, we are talking about ratio. So when I say 25 is to 24, that means 25 over, when you add them up, 49, that is the milk ratio. So initial amount we can take as ratio. You understand? So the initial amount can be taken as a ratio, and then we could actually solve this question. Now the ratio is 100%. You see this is 100%, so 1 out of 1. So this ratio is 100%. That means 1 out of 1. Is that clear? Or you can say x over x, whatever you want to write, right? So now, using this, we'll use the ratio 25 over 49 is equal to, you can say x over x or 1 out of 1, right? So ratio we are taking times 1 minus. What is removed? 20 liters, right? So 20 out of what? We don't know. You could actually write x also here, x out of x, one and the same thing, right? Because we are writing it in ratios. So I hope you understand this step, right? So the initial amount has been taken as a ratio. You can write x over x or 1 over 1. Total is x, which we don't know. And this process has been done twice. 20 liters is withdrawn and replaced with water. 20 liters of mixture is again withdrawn and replaced with water. So we get to the power of n as 2 here, right? Okay. Now we can do square root. So when you do square root of this, which is square root of 25 over 49, which basically is 5 over 7, right? Equals to 1 minus 20 over x, correct? So now we can calculate the answer. So we get what? We get 20 over x equals to 1 minus 5 over 7, which is 7 minus 5 is 2, 2 over 7, right? So we can get x with cross multiplication. So we get 7 over 2 equals to x, right? So that goes 10 times. So we get 70 equals to x as our answer. So we started with the initial amount of 70 liters, right? So our answer is x equals to 70 liters. That is the initial amount. So I hope the steps are absolutely clear, right? Now here is question number 7, which says, from a vessel of milk, 20 liters is withdrawn and replaced with water. 20 liters of mixture is again replaced with water. That means 2 times. The vessel now has 18 liters of milk. Find the initial amount, right? So we're not talking about ratios this time. We're talking about full amount, right? So we can say what remains is equals to initial over 1 minus removed over total, right, to the power of n. Now what remains is 18 liters. We don't know what initial is, and we have 1 minus. We know 20 has been removed from whatever, and n has been done 2 times. So that is the situation. Now this type of an equation is very difficult to solve, right? Earlier we had to do square root. It was easy, but this x is also outside, right? So this should be solved with trial and error. You get an idea, right? So what you could do here is you could substitute some values of x and check. So what we will do here is we'll write some values of x and then calculate. So let us say let x equals to 40, for example, right? So in that case, what do we get? We get 40 times 1 minus 20 over 40 whole square, right? So that gives you 40 times, this is like 1 over 2, right? So half minus 1 over 2 is 1 over 2 square, and that gives you 10, not 18, correct? So that is not correct. So we can now try the second, which is, let us say x equals to 50. You have to guess and check. Sometimes if it is a multiple choice, you could select with those, right? So we get 50 times 1 minus 20 over 50, right? Which is 2 over 5 to the power of 2. So which is 50 times 2 over 5. When you take away, you get 3 over 5, right? Square. Well, that is 50 times 3 square is 9. And 5 is 25, and that indeed gives you 18, right? That goes 2 times. So that works. So our answer is 50, right? So we get the answer. Let me write in different ink, 50 liters. Does make sense to you? So that is how you should be answering. Now here is the last question, which I'll use as a test question for you. It says, a mixture contains milk and water in the ratio of 3:2. 10 liters of mixture is removed and replaced with water. The amount of water and milk now becomes exactly same. Find the initial quantity of milk in the mixture. So you can pause the video, answer this question, and then look into my suggestions. Now here I'll adopt a different method. We're talking about milk and water, and the ratio is 3:2, right? It says find the initial quantity, we don't know, of milk, right? So let it be 3x and let be in the ratio of 3x and 2x. So we are working with total of 5x. So if 5x is the total quantity, 3x is the milk, 2x is water. They are in the ratio of 3:2. Now see what is happening here. It says 10 liters of mixture is removed and replaced. So when I remove 10 liters of mixture, that means 10 liters removed, the ratio will be 3:2 only, correct? So that means it is 6 and 4. So we removed 6 from here and we removed 4 from there, correct? And then it says replaced with water. That means all 10 liters was added water, right? So added water. And then it says the amount of water and milk now becomes same, right? So let me just underline this, which says amount of milk and water now becomes same, right? That means this is milk. Milk is what for you? Milk is 3x minus 6. That should be equal to 2x minus 4 plus 10. Is that clear to you? So we get our equation, from where you can find what 3x or x is first, and then you can find what 3x can be, right? So let's solve it. So we get 3x, let me write 3x minus 2x first, and taking 6 on this side, we get this as 2 plus 10 as 12, right? So that means x is equals to 12. If x is 12, how much is the milk? So we know milk is equals to 3 times 12, which is 36 liters. So that is how we can actually solve the question. So find the initial quantity of milk in the mixture. Initial quantity of milk in the mixture is 36 liters. So that is how we'll actually end our series on mixtures, where we have taken all the examples related to removal and replacement. So that's a huge set of videos for you. I hope that should definitely help you to answer any question based on this concept. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.